let's think about numbers of things, and the things in question are going to be, I'm going to draw as little squares. So that's one square. Alright, now suppose I want to make a square that has two ones on each side, so I put two together. So that's an oblong. So to make a square we've got to put another two down here, one there, and that's supposed to be a square. Now we've got two along that side, and a square has sides of equal length, so there are two on that side. And how many squares in total have we got inside this big square? How many squares in total? Well, there are 1, 2, 3, 4, which is two lots of 2. 2 times 2. 2 times 2. Now suppose we want to make a square with 3 sides made up of 3 of these squares. So that's 1, that's a big oblong. I'll need another lot of 3, but we've got 2 lots of 3. That's only 2 down that way and 3 across there, so I'm going to need to put another row on here and another 3 on there. And then this big square here is indeed a square because it's got 3 along that side and 3 along that side. Now how many little squares make it up? Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 3 lots of 3, so 3 times 3. So there'll be 3 times 3 squares, little squares, inside this big square, the sides of which are 3 long. And we can do the same. Let's suppose that we have a square, big square here, and let's suppose it's got sides of length 8. So we've got 8 across, and I'm just drawing 8 down. Right, so that's 1, 2, 3, 4, 5, 6, 7, 8 that way. And how many down? 1, 2, 3, 4, 5, 6, 7, 8 down. Now how many little squares are there? Well, I could count them all, but there's no need to count them all because all we need to do is just to multiply. We know there are 8 lots of 8. 8 piles, a pile, 8 high, of these 8 squares across. So it's the number of squares in there are 8 times 8. And what is 8 times 8? As a matter of fact, that is 64, and 3 times 3 we know are 9. We've already counted that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, that's right. And 2 lots of 2 is equal to 4. Now you'll notice that these are kind of interesting, aren't they? 2 lots of 2 are 4, 3 lots of 3, that's the same, are 9, 8 lots of 8. Now instead of writing 2 times 2, what we can do is write, what we sometimes do is simply to write this, a 2 there, and then we put a little 2 at the top of it. And what that means is that we write 2 out 2 times. This is what we write it 2 times, and we put a multiplication sign in there, so, and that equals of course 4. And the same here, 8 squared, 8 times 8. 8 squared is, we call it squared when we've got a 2 up here, and for the very reason that it's the number, it gives us the number of little squares in a big square with 8 sides of length 8. 8 squared means, it's just another way of writing 8 times 8, and that is 64. Now we can use this notation, this way of writing 8 times 8, just using 1 8 and a little 2 to show that there are 2 occurrences of 8 here. We can use that for other expressions. Suppose we want to write 8 times 8 times 8 times 8. Now that's boring, writing it right out long ways like that. There's another way of writing it, and we can write 8 with a little number up here up top. That's the number of 8s, how many times do we multiply them together? Well, there's 1 8, 2 8s, 3 8s, 4 8s. So 4. So 8 times 8 times 8 times 8, that's 4 lots of 8s multiplied together, is equal to, just can be written another way, 8 with a little 4 up the top here. And then we say, when we write something like that, we say that is 8 to the power of, that's supposed to be of 4. 8 to the power of 4. When we say to the power of 4, it just means we multiply it together 4 times. 4 of those 8s are multiplied together. Let's do it again. 8 to the power of 3 is just another way of writing 3 8s, and then between them we put multiplication. We put multiplication signs. And that's just a matter of notation, a matter of words. So just to tell you what those words to the power of mean. Now I've just said that when we raise a number to the power of 2, what we say we're doing is squaring that number. So 2 raised to the power of 2, which is to say 4, we say that's 2 squared. Why? Because that gives us the number of little squares in this big square. And same here, 8 squared is 64, because 64 is the number of little squares in this big square made up with sides of length 8. Okay, so those are squares. Now suppose I want to draw not a square but a cube of, well, sides of length 2. So this is the base of the cube. You know what a cube is. It's like a box. And it's a big box like this. Does that look like a box to you? And it's got sides of length 2. So there are 2 along there. 1, 2. 2 along there. 2 along that back side. And 2 along there. And we're making it a cube. So it's got 2 there. Now what have we got? How many cubes, little cubes, have we got inside that big cube? Well, we've got 1 box, 2 boxes, 3 boxes, 4 boxes, times 2. 1 box, 2 boxes. How many boxes was all of that? That's this. Well, we've got here in this bit here, in that bit of the cube, we've got 1, 2, 3, 4, and then we've got the same over here. So we've got 4 plus 4, 4 plus 4, which equals 8. We've got 2 lots of 2 multiplied by 2. So we've got 2 lots of 2, which is 2 times 2, all multiplied by 2. And that, another way of writing that, is 2 to the power of 3. Now when we have a number to the power of 2, we say that that is squared, 2 squared. When we have a number to the power of 3, we say it is cubed. 3 2's multiplied together to the power of 3 is 2 cubed. And we say it's cubed because just in the sort of way that we say this is square, because it's the number of little squares in the big square, because it's the number of little cubes in a big cube. Now, squares and cubes and numbers raised to a particular power, or some power, are useful and interesting for a whole variety of factors, for a whole variety of reasons. But let me just show you what some of those reasons might be. Let's suppose we have a number, what should we say? Let's use the number 2. We have 2 squared, and we want to multiply that by 2 cubed. What does that mean? That means 2 squared means 2 times 2. Okay, they're just two lots of 2, because that's what the 2 up here means, multiplied by, and here we have 3 2's. 1, 2, 3, multiplied by. Now, how many 2's have we got? Let's express this. That's that 2 cubed, and that's 2 squared. Right, now let's express this in a power notation. That is equal to 2 to the power of what up here? Well, it's the number of 2's. 1, 2, 3, 4, 5 is 2 to the power of 5. So what does that mean? It means that, and again, let me just write this in a different color. What we've just shown is 2 to the power of 2 multiplied by 2 to the power of 3 is equal to 2 to the power of 5. In other words, it's equal to 2 to the power of 2 plus 3. Although we're multiplying these numbers together, in order to get the result, we add these two. See how it's a way, in effect, of changing a multiplication into a straightforward addition. And remember how much easier it is to add numbers than it is to multiply them together. So 2 to the power of 2 plus 3. Now, we're not going to go into too much detail about it here, but we use this fact to make multiplication, for example, a lot easier. And let me just show one of the ways that we can use this fact, these powers, to make multiplication much easier. Now suppose we have two numbers that we want to multiply together and that they're difficult numbers to multiply together. Suppose they're, for example, well, let me just pull two numbers out of the air, 237, and we want to multiply that by, for example, 1126. Now we could multiply those together and that would be pretty boring to do, but there's another way of doing it using this fact about powers. We know that 237 is equal to 10, for example. Doesn't have to be 10, but we count in tens generally, so let's consider 10 for the moment. Is 10 raised to a certain power x? I don't happen to know what x is at the moment. I could look it up on a set of tables, and we know that 1126 is a number equal to 10 raised to the power of y. Now if that's true, if 237 is 10 to the power of x, and whatever x happens to be, I don't know, I could look it up, and 1126 is 10 to the power of y, then what is 237 multiplied by 236? Well, as we've just discovered, it is 10 to the power of x plus y. And so all now I have to do is to add x and y together and then to look up and find out what number is arrived at by raising 10 to this number that I've just worked out by adding x and y to the power of x plus y. And I can just look that up. I can just look up on a set of tables what is 10 to the power of whatever this number here is, x plus y. And we call doing multiplication that way, we call that doing multiplication using logarithms. Now I don't intend to go here into any more detail about logarithms. You'll come across them later in your life as mathematicians. They're kind of interesting, but I just wanted to show you how they enable us to do difficult multiplications quite easily simply by adding powers.